Hello, hi everyone. Welcome to the Student the Brand. This is your Siva sir. Happy Independence Day to all of you. Now we are going to discuss about projectile motion, CBSE grade 10, grade 11. So generally we are used to discuss grade 10 like that, right? So grade 11, CBSE grade 11 physics. So in motion in a plane, in the topic projectile motion. Projectile motion we are discussing. Okay. Normally, when you are throwing the objects, when you are throwing the object from one point to another point, so we'll throw like this. So we'll throw like this. Yes or no? And so we are okay. Obliquely we are throwing the object, means with the ground. If you are taking with the surface, so we are making some angle and throwing the object. So that is called obliquely. Oblique motion means with certain angle. With certain angle. Okay. So we are throwing the object. So it moves in a projectile motion, right? Here, if the body moves along this straight line, so it is called one dimensional. If the body moving, making some angle with the help of x-axis and y-axis, we will say two-dimensional motion with the constant acceleration here. With the constant acceleration, the body is moving with the constant acceleration, right? So it depends on the how you are throwing. It depends on how you are throwing. Okay, so based on that one, different types of projectile motion. Now, few examples. So mainly we'll discuss today this one with the object. This is the x-axis and y-axis. Okay, so we are throwing the object like this. Initial velocity is u. Initial velocity is u. So here I can take angle. I can take alpha. I can take alpha. You can take theta also fine. So some angle. With certain angle, the object is thrown. Okay, the object is projected. Trajectory means path of the particle moving. Okay, in which path the particle follows. That path is called trajectory. Trajectory of a particle. So that is projectile motion we are considering. So here projectile motion, it making certain angle with the ground and moving like this. Okay. And here different types I'm considering here. So if you're taking on the ground, this is the ground. So from here, certain height we are throwing the object like this with certain angle. And from here also, same height. So we are taking the object like this. So we are throwing the object from certain height. So we are throwing the object from certain height. So from this side we are throwing the object. Anyway, the body moving like this. So it moves with certain angle. So with velocity u, with certain velocity u, and here also certain velocity u. And an inclined plane also, if you are taking inclined plane, so today we'll discuss only the object. Okay, so it is making certain angle with the ground. So we will discuss only this one. Later we will discuss about projectile motion on inclined plane. Projectile motion on inclined plane we'll discuss later. As of now we are discussing, okay, so object is thrown with certain angle with the ground. So we are tracking like this x-axis, and this is y-axis, x-axis and y-axis with the constant acceleration. So throughout the path, object moves with a constant acceleration, right? Okay. So it is making certain angle at the same time is thrown. So if you resolve the component, along x-axis unit vector is I cap, along y-axis unit vector is j cap. So once again now, be careful, listen careful here. So along x-axis unit vector is I cap, along y-axis unit vector is j cap. Along x-axis unit vector is I cap, along y-axis unit vector is j cap. Okay. So you know, if you are taking this x-axis and so if you are taking alpha, this x-axis and y-axis, so u is the initial velocity of the particle. U is the initial velocity of the particle. If you resolve the u value, so u into two components along x-axis and y-axis, So now you can see. Okay. So u bar, u I am writing in the format of ux I cap plus uy j cap. Ux I cap, uy j cap. Along x-axis and along y-axis. Okay, so that is x-axis component and y-axis component, that is ux and uy. Now, if you resolve the component, okay, so what is cos alpha? What is the cos alpha formula? Of adjacent side by hypotenuse. Adjacent side is x by u. That is, I already said this is, we can also write like this also, x I cap plus y j cap also we can write. So components. As I said, ux is the component along x-axis, y is the component along y-axis. So now in this case, because whatever we are getting in the format of x and y, that is the reason we are writing like this. Okay, so x equal to u cos alpha, and sin alpha if you are taking y by u, that is y equal to, from here, y equal to u sin alpha. Okay. Now overallly we can write u equal to, so x is how much? U cos alpha I cap plus u sin alpha j cap. U sin alpha j cap. Okay. So at any time, suppose if you are taking here also, so along x-axis, along y-axis, so u value is there. So it is making a angle alpha. Along x-axis u cos alpha, along y-axis u sin alpha at any time. So it is the maximum height. So this is the maximum height. So here is the maximum height, and this is the maximum distance, displacement if you are taking. This is the maximum range we can consider. This is the maximum height, exactly at the middle. From there onwards it starts falling down. So until here it is moving up. Again after this point it is coming down. Okay, so at this point vertical velocity becomes 0, Vy becomes 0, so be careful. Final velocity becomes 0, and still initial velocity will be there, that is along x-axis you can take u cos alpha, so that is constant throughout the path, but acceleration is 0, ax equal to 0, ax equal to 0, along horizontal direction ax is 0, because u cos alpha is same, so throughout the path, here and here along x-axis, I will tell what is x and what is y, so what is vy, what is vx, I will write. Okay, so until here I hope it is very clear to you all. So is it clear until this point? Until this point I hope it is very clear. Once again listen carefully. So we are discussing about projectile motion. Bodies, so particle is moving with certain angle with the ground. So if you are taking along x-axis, if we take along x-axis, so with x-axis alpha, so it is moving. Okay, so the path of the particle is called trajectory. So the path is called trajectory. So that is the projectile motion. The entire motion is called projectile motion. Okay, projectile motion. Okay, so it is making with certain angle alpha. So it's making certain angle alpha. So we are throwing the particle with certain angle certain velocity. Anyway, certain angle with the x-axis alpha. Okay, so we don't know. We can take 30, 40, 50, 60, less than 90, right? Like 90 means perpendicular to x-axis. That is 90. Less than 90 we are taking. So if you take, this is the theta. So we can also take theta also. Sir, why you are taking alpha? We can take theta. Yes, we can take theta also. Fine, no problem. No issue. Same thing. So similar. Instead of alpha, we will take theta. That's enough. Okay. Now, along x-axis, y-axis, we discussed. Okay. So throughout the path, ux is u cos alpha and acceleration is 0. Here, if you resolve the component u value along x-axis and y-axis, cos alpha equal to x by horizontal component by hypotenuse. Okay, horizontal by hypotenuse. So x by u. So x equal to u cos alpha. And vertical component, so sin alpha equal to opposite side by hypotenuse. Opposite side by hypotenuse. Then sin alpha equal to y by u, so y equal to u sin alpha. So like this we have to resolve the components. Already I did one video. So I did one video on this resolving the components related to vectors topic, scalars and vectors. I explained in that video. So very clearly explained. So once you go and check the video, scalars and vectors I explained very nicely. How to resolve the components along x-axis and y-axis. Okay, go and check once. So cos alpha equal to x by u, x equal to u cos alpha, sin alpha equal to y by u, y equal to u sin alpha. So this is a process of resolving the component along x-axis and y-axis. So you know u value along x-axis and y-axis. As I said, I cap, j cap, I cap is along x-axis, j cap along y-axis, and k cap is along z-axis. These are the unit vectors. Okay, I cap is a unit vector, j cap is a unit vector, k cap is a unit vector. I cap along x-axis, j cap along y-axis, k cap along z-axis. These are the unit vectors. I cap along x-axis, j cap along y-axis, k cap along z-axis. Okay, so like that, u along x-axis ui, so ux I cap plus uy j cap. That is also I already said. So this is a component along x-axis. Component along x-axis. So we can also take a component along y-axis. So that's why u equal to xi cap plus yj cap. So as we got x and y value, you can substitute in this. That is, so u equal to xi cap plus yj cap. So u equal to u cos alpha I cap plus u sin alpha j cap. I hope it is very clear to you all, right? Now, final velocity at any time. So at any time, what is the final velocity and the displacement at any time, at a certain time. Okay, and this can be written in along x-axis and y-axis, along horizontal components, along vertical components. How we can write along horizontal components and along vertical components? How we can write? So we will see that. Okay. Now we know equation of motion. If the body moves with a constant acceleration, the body moves with a constant acceleration, what are the equations of motion? So v equal to u plus at, first equation. Second equation is s equal to ut plus half at square. And the third one is v square minus u square equal to 2as. So I already explained, I already derived these equations. I explained at the same time I derived. So these equations from graphical method and also from integration method also I explained these equations. So once go and check in the playlist. Okay, light reflection refraction. So go to the playlist and scalars and vectors, if you type also you'll get it in my channel. So derived with the graphical method and integration method also these equations. So that's why I'm writing directly. These are the equation of motions. If the object moves with a constant acceleration, v equal to u plus at, s equal to ut plus half at square, v square minus c square equal to 2as. So along x-axis and y-axis and so along x-axis and y-axis, how we can write? Because we are taking a two-dimensional motion. So projectile motion is a two-dimensional motion. Okay, so we are taking in this case. Okay, so Vx along x-axis and along y-axis. Simple. So if you are taking only horizontal component, so these are the horizontal components, and this one is the vertical component. Okay, so along x-axis, along y-axis, we are discussing. Along x-axis, if you are considering here, Vx equal to ux plus ax into t. So anyway, time is same only, right? So sx equal to ux t plus half ax t square, and vx whole square minus ux whole square equal to 2x and coming to y-axis, vertical component. Now vy equal to, you can see here, vy equal to uy plus ay into t, and sy equal to uy into t plus half ay into t square. Okay, so ay along y-axis we are taking, along y-axis. If the object is moving upward direction, so acceleration due to gravity always it acts downward direction. Acceleration due to gravity always it acts downward direction. If the object is moving upward direction, so along y-axis we can take negative g. Okay, so acceleration due to gravity is minus g. So I'm taking minus sign g by. So if it is vertical component, so j cap I am taking. If it is x-axis, anyway 0, right? Horizontal component, That is nothing but ax equal to 0, ay equal to minus g. So here again by whole square minus uy whole square equal to 2ay and sy. Okay, so along x-axis and along y-axis we can write like this components. Okay, x-axis is called horizontal component, y-axis is called vertical component. Horizontal component and vertical component. These are the equation of motion. V equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2as. I hope it is very clear to you all. I hope it is very clear, right? Now we'll go to the next one. That is, so final velocity and displacement at any time. So initially we consider at any time. So at any time. So at any point, at certain time, at the time t. So what is the final velocity? What is initial velocity? What is the final velocity and what is the displacement? We will discuss. What is the displacement? We will discuss. Okay. So now let's start. So already we resolved the components along x-axis and y-axis, right? Along x-axis we resolve the components, along y-axis also we resolve. Now final velocity at the time t. Okay. So at the time t we are discussing at the time t. At the time t, what is the velocity and the displacement we will discuss. From equation of motion, we know, right? We know that v equal to u plus at, v equal to u plus at. Yes or no? So along vertical component, so we are taking u value, okay, and s equal to ut plus half at square. Okay, na? So these equations we will write in the form of horizontal component, vertical component. Okay, now let's start. Here u value already I discussed. U value is u cos alpha I cap u sin alpha j cap. Okay, and a value is minus g j cap. Okay, so that is ay. Anyway, vertical component only it will be there, horizontal component anyway it will become 0. So body at a time. So at any time means object is moving upward direction. Okay, so then now we can take here, that is v equal to u cos alpha I cap plus u sin alpha j cap. Okay, plus minus g j into t. So j cap into t. Now, so take all I cap one side and j caps one side. So here I am taking. So in these two only j cap is there. V equal to u cos alpha I cap. So j cap I am taking common. U sin alpha minus gt. Okay, j cap. Anyway, j cap is there. Or if you can write at the end also, fine, no problem. You can write here also, fine. J cap. I hope it is very clear to you all. So v equal to u cos alpha I cap plus u sin alpha j cap plus. So here along y-axis, so we consider that is a equal to minus g j cap. So if you substitute, you'll get it v equal to u cos alpha I cap plus u sin alpha minus gt j cap. Coming to this one, s equal to ut plus half at square. S equal to U means U cos alpha, I cap plus U sin alpha j cap into T plus half into minus j cap into T square. Okay, so now observe carefully while I'm writing these equations. We must focus. So because if you even one thing if you miss also entire things will go wrong. So focus on these equations. Okay, chalo then. S equal to, so U cos alpha I cap. So anyway, under T is there here. So U T cos alpha I cap plus, here we can take j cap common, ut sin alpha minus, here minus is there, 1 by 2 gt square into j cap. Clear? So u into t sin alpha j cap plus minus 1 by 2 g t square, anyway j cap. So we took common. So this is the displacement. Okay, I hope it is very clear. Check once. If you have any doubts, let me know. Okay, so and one more thing, today onwards we started assignments like assessments and like a test series we started for grade 10 we started. Once you go and check the community post, so I posted, check once. And for grade 11 and grade 12 also we are going to start the test series, like whatever the topics we completed, based on the topics, so questions will be posted. Okay, so in the blogger it will be there, you can follow the blogger. Okay, you can check, you can go and visit. So yesterday posted, today onwards we are going to implement, right? That's fine. Today onwards for grade 11 grade 12 also we are going to start. Once, check the questions for grade 12, grade 10 I posted. Okay, for grade 11 and 12 also today onwards will start. So now we are going with the projectile motion. Okay, so projectile motion. So grade 11 physics, grade 11 physics. So people can, those are attempting JEE NEET also, you can attend, because important concepts we are discussing. Okay, I hope it is very clear to you all. So check once. If you have any doubts, you can ask. Then we'll go to the next one. Okay, now along x-axis, if you are considering along x-axis, So S equal to ut plus half at square. Okay. Along x-axis, so acceleration is 0. Along y-axis, a equal to ay equal to minus g. Then along x-axis, you are writing x equal to u cos alpha t. Anyway, ax. So initially I explained along horizontal components and along vertical components I given the equations. So this entire term becomes 0. Then x equal to u cos alpha t. Now if you want t value, t equal to x by u cos alpha. As I said, so we can take alpha equal to theta also in some books. In H.C. Verma, so they consider angle is theta. In D.C. Pandey, so they given alpha. Okay, check once angle you are mentioning. So that is very important. Okay, t equal to x by u cos alpha. Now y. So in the case of y, if you are taking ut plus half at square. So y equal to, along y axis I am taking uy equal to u sin alpha t plus half into g into, so t square minus g, right? Minus g t square. So that's why y equal to u sin alpha t minus half into gt square. Now in the place of t, okay, here in the second equation I am taking this the first equation, equation 1 and equation 2. If you substitute equation 1 in equation 2 or t value in equation 2 in easy way, so t value in equation 2 you'll get it, t value t equal to x by u cos alpha. Now y equal to u sin alpha into x by u cos alpha okay, minus half into g into t value how much, x by u cos alpha whole square. Yes, check once here, y equal to u sin alpha into, in the place of t, so I am substituting x by u cos alpha minus anyway of 1 by 2 into g into, in the place of t I am substituting same value, x by u cos alpha whole square. Okay, so then you'll get it, so you are taking, so I am substituting, right, t value, so you can check once. Now you'll get it, y equal to x by, so you get cancel, x by x into, so here you can take y equal to x into sin alpha by cos alpha minus 1 by 2 into g x square by u square cos square alpha. Okay, so here how much, tan alpha x into tan alpha here check once. So sin alpha by cos alpha how much, tan alpha, right? Sin alpha by cos alpha, what is this one, tan alpha minus 1 by 2 into gx square by u square cos square alpha. Yes or no? Now x into tan alpha minus 1 by, so gx square by, okay, so 2u square cos square alpha. So the trajectory of the particle is a parabola. So this is the equation, y equal to x tan alpha minus, so g x square by 2u square cos square alpha. So 1 by cos square alpha secant square alpha. Secant square alpha we can write 1 plus tan square alpha also we can write. Still we can extend this equation in multiple forms. In multiple forms we can write. Okay. So until here it is clear. I hope it is very clear to you all. Just check once again. Horizontal component, vertical component. So from starting onwards, you have to keep in mind. So horizontal component and vertical components. You should be very clear with that. So if you don't have an idea on it, then you'll get confused. Okay. So first, you must take along x-axis and y-axis. Along x-axis and y-axis. So x-axis horizontal component, y-axis vertical component. Along x-axis horizontal component I am considering. So equation of motion v equal to u plus at, s equal to ut plus half at square, v square minus c square equal to 2as. Okay. So we have to keep all those equations in mind. We have to keep all those equations in mind. While solving, while writing, you must focus on it. Okay. So you have to be very clear with the concept. S equal to ut plus half at square, we are taking this equation. So along x-axis I am taking. Along x-axis component. Okay. So x-axis if you are taking. And this is the along y-axis. Along y-axis. So when you are taking x-axis, you have to take all those components along x-axis. What are the components are there? What are the conditions are there? So along x-axis, when the particle you are taking, so anyway it is a projectile motion, two-dimensional motion along x-axis and y-axis. So we divide it into along x-axis and y-axis. If the particle, whatever we are taking the components of the particle along x-axis, components of the particle along x-axis. So those are s equal to ut plus half at square. So along x-axis, so distance x I'm taking. Okay. So if you are taking displacement is also x. And u cos alpha, anyway x-axis we are mentioned. So we mentioned. So that's why we can directly you can consider here along x-axis. So x equal to u cos alpha t plus here. Why this entire term along x-axis 0? Because so throughout the path u cos alpha is same. U cos alpha, u cos alpha, u cos alpha is same. Okay, constant. That's why acceleration is 0. Okay, acceleration is 0. That's why I'm taking along x-axis. Anyway, acceleration due to gravity will be there. That is. So ax equal to 0. That is, so that's why equal to ax equal to 0. That's why entire term becomes 0. Then x equal to u cos alpha into t. T equal to x by u cos alpha. Coming to y-axis, x equal to ut plus half at square. Y you are taking. So along y-axis, this time along y-axis, so you have to keep in mind vertical components. When you are doing horizontal components, you have to be in that path. Okay. What are the components are there? How you are taking? Everything you should be think about x-axis. When you are coming to the y-axis, you have to think about only y-axis. Okay. If you have to think along y-axis. So if you are going through along y-axis, what are the components? So y equal to u sine alpha t plus. So I already said ay equal to minus g t square. Okay. So y component y equal to u sine alpha t minus half gt square. So we are substituting t value in the place of, okay, so in the second equation. So t value t equal to x by u cos alpha, that is equation 1 I am considering. So equation 1 if you substitute in equation 2, you will get x y equal to x tan alpha minus g into x square by 2u square cos square alpha. Okay. So the trajectory of a particle is a parabola. So by this we can conclude that, okay, projectile motion. Okay, so check once. So if you have any doubts, you can let me know. You can ask. I hope it is very clear to you all. Now one more. So we will discuss about time of flight. Time of flight. Okay, time of flight, maximum height and maximum range. Time of flight, maximum height and maximum range. Okay, check once. So check once carefully. So we'll go to those. Okay then. So are you ready? So if you are ready, if you are there, if you like the content, if you like the concept, if you like the explanation, so please click on like button. Okay. So time of flight. So I'm going to take flight. So that's why. So everything is ready. So all set. Now ready to take flight. Okay. Here the particle, the time taken by the particle to fly in air. Okay. So from here to here. That's why vertical component we are considering. So same formula S equal to ut plus half at square you can take. So first we will consider the vertical components conditions. Uy equal to, what is the formula Uy? So along y axis, can you tell me? Along y axis? Along y axis, anybody? Along y axis. Uy equal to u cos alpha, sorry, u sin alpha, u is equal to u cos alpha, and Ay I am taking Ax is 0 along x-axis, Ay equal to minus g. So these are the conditions. These are the conditions I am considering. Okay. So conditions, is it clear or not? Conditions. So observe these conditions carefully. So be careful with the conditions. Uy equal to u sin alpha, ux equal to u cos alpha, ax equal to 0, ay equal to minus g. Now, so sy equal to uy into t plus half into ay into t square. So I'm giving the points 0 and this is the maximum height and b I'm taking here. So along y-axis, if I am considering, if the object is thrown upward direction, only y-axis. So upward we thrown, so again it reached to the ground. So vertical displacement is 0. Vertical displacement is 0. So we have to write like this also. Sir, why vertical displacement is 0? Because along y-axis, as I said, along y-axis only you have to think. Along y-axis only you have to think. So in that, if you are thinking along y-axis, it's a 0 because we thrown. So the time taken by the body to fly in air. So from starting to until here, okay, how much time it is taken to fly in air? That is called time of flight. Okay, a time of ascent and time of descent, time taken by the body to reach the maximum height is called time of ascent, time taken by the body to reach the ground from maximum height is called time of descent. So time of flight is nothing but time of ascent plus time of descent. So that also we can time of ascent plus time of descent. Now you can see here u sine alpha into t plus 1 by 2 into minus g into t square. Okay, so half into g into t square equal to u sine alpha into t. Okay, so anyway you can take common also, t equal to 0 or t we can cancel it also. We can cancel t, otherwise from here if you are taking common in this equation, if you are taking common t equal to 0 also we can take. Anyway, so we need only 1t get cancelled, then 1 by 2 into gt equal to u sine alpha. So now you can take from this t equal to time of flight. So 2u sine alpha by g. That is a formula. Check once here. 1 by t into g into t, that is u sine alpha. T equal to u sine alpha. 2u sine alpha by g. Is it clear? This is the time of flight. So capital T if you are taking time of flight. So 2u sine alpha by g. Is it clear? Check once. Check once. If you have any doubts, you can ask. You can let me know. Okay. So next, I'm going to the next one. This is the time of flight. Keep in mind. So all the equations at the end I'll write. So I'm writing this side. T equal to 2u sine alpha by g. This is equation number 1. Next we'll discuss about maximum height formula. Okay, so this is the maximum height. So if you throw the particle, if you project the particle with certain angle along with the x-axis, if you project, so until here it reaches, that is the maximum height. From there onwards it start falling down. Okay, so this is the maximum height. At A I'm taking here, I consider at A. So this is the maximum height. Okay, ready. Now maximum height, maximum height. Okay, check once here. Vy, so normally formula, right? Main formula, right? Then you will get to know. The main formula is v square minus v square equal to u square plus 2as, or v square minus u square equal to 2as also we can write. Okay, so we can write v square minus u square equal to 2as. That's fine, right? We can write, no problem. Now vy whole square equal to uy square plus 2ay and sy. So this is the maximum height. That is, I am taking this the maximum height. Where we'll get maximum height? So now conditions. What are the conditions we need to substitute? So condition number 1 is sh equal to h. That is the maximum height. We are finding maximum height formula. Uy equal to along y-axis u sin alpha, and vy at the maximum height. So 0. Now you substitute all those conditions. Once again, maximum height h and uy equal to u sin alpha. Okay, initial this is I am taking initial. Okay, so at maximum height is 0, but initial it is there, uy equal to u sin alpha. And yeah, ay, you know, ay, what is ay value? Anyway, minus g. Ay is minus g. Okay, because vertically, along vertical direction I am taking. So now you substitute here. 0 equal to u sin alpha whole square plus 2 into minus g into h. Now, so you can take this entire term, 2gh equal to u square sin square alpha. Yes or no? Is it clear? So 2gh equal to u square sin square alpha. So as you have to remember this one, as I said, alpha equal to theta. Okay, so we can take any one among those two. So h equal to u square sin square alpha by 2g. Is it correct or not? If it is correct, click on like button. If not, no problem. Okay. Is it clear? Is it correct? Okay, done. So write the formula. h equal to u square sin square alpha by 2g. Now we will take maximum range. So we will take the maximum range. Okay. So maximum range is nothing but this much only, right? How much distance? That is only displacement. How much distance it is traveled from point of projection. From point of projection to until it reach the ground. Okay. So this is called maximum range. Okay. So angle may be different, but so we are considering that is a range, maximum range. So I wrote these two equations. Initially you got time of flight 2u sin alpha by theta, sorry g, and the maximum height is 2u square sin square alpha by 2g. Now we will find out maximum range. Maximum range. Is it clear? Shall I? maximum range. So the maximum range, normally I said along x-axis we are taking, range means horizontal component, we are taking S equal to ut plus half at square. Ut plus half at square. So I hope, so we need to take the conditions first. What are the conditions? Anyway, S equal to x along x-axis. So u equal to u cos alpha, yes or no? And ax equal to 0. And t here, time of flight, time taken by the body to reach that point from here to here. So total time, that is called time of flight. So total time, time of flight is how much? Here I wrote. That is the reason I wrote here. T equal to 2u sin alpha by g. T equal to 2u sin alpha by g. Okay, substitute now. So x equal to here u cos alpha, okay, so u cos alpha into t, time of flight. Anyway, this entire term becomes 0. Why? Along x-axis, acceleration is 0, right? Velocity is constant, ux equal to u cos alpha. So that's why, so this is the x-axis only, x. So u cos alpha is constant, so acceleration is 0. Ax is 0. That's why I'm taking here. This term becomes 0. Then x equal to, that is the maximum range only, right? Horizontal component, shall I write maximum range? So while I'm substituting t only, I'll write maximum range, that is r. R I am writing. U cos alpha into 2u sin alpha by g. Okay, so now r equal to 2u square, u square 2 sin alpha cos alpha by g. That is nothing but sin 2 alpha. Okay, so 2 sin alpha cos alpha equal to sin 2 alpha. So maximum range equal to u square sin 2 alpha by g. Okay, so this is the formula. This is the maximum height, time of flight, maximum height and maximum range. Range, see, actually this is the range. Maximum means when it will be maximum, when you are taking the angle, depends on the angle. So we found the height. This is the height. Okay, maximum height will get here. And the distance, the maximum distance, the particle range, that is r. Okay, so range. This is a range and the height. Okay, depending on the angle, it will reach. Yes or no? So is it clear? Check once. If you substitute alpha 45, you'll get a maximum range and maximum height. Alpha is 45 degrees. Check once. Is it correct or not? Check once here. So if you substitute sine 245, 90, sine 91, u square by g. That is the maximum range. Here also sine square 45. So 1 by 2, 1 by 2, 1 by. Okay. Is it clear? So check once if it is okay, means let me know. Sir, if any changes are there, if you have any doubts, substitute alpha 45 degrees, alpha equal to 45 degrees. Will you get maximum range? Is it correct? Let me know. Okay. So thank you so much for joining and attending and listening the class and giving an opportunity to take the class. Okay, so substitute alpha value and find out T value and H value and R value. That is a homework. Okay, homework. Yes or no? Find the time of flight and the maximum height and range. So thank you so much for joining and attending and listening my class. So if you like this video, do like, share and subscribe to Student the Brand. If you like the content, you can subscribe and you can share to your friends, ask your friends to join to the class. So this is our Seva sir from Student the Brand. Thank you so much and we'll see you in the next class. Thank you.